Okay, that one we already talking last time, right? Okay, that means your voice go to the speaker, okay, they go to the amplifier, but that will be analog signal. So basically, they have to converting, okay, into the digital, then your voice can go into the speaker, okay? And now, first thing basically you need to know about the number system. First number, decimal, everyone already know. The 0, 1 up to 9. Total will be 10 digits. That's why they call it base 10. 10 digits. Okay? Binary number, you get only 2 digits, either 0 or 1. Why they get the name base 2? Octal, 8 digits, 0 to 7, base 8. Hex, decimal number, they get 16 digits, so that's why base 16. Okay? And now the binary to decimal conversion. Make sure everyone know how to do it, okay? If you get a binary 11011, remember, inside the computer, only the computer can understand a binary, either 1 or 0, nothing else. When you're typing, okay, decimal number 9, for example, the computer cannot understand number 9. However, they get a device to converting number 9 in a decimal into the binary number. So the computer can understand. That's what happened inside your keyboard. They have to get that device. Okay? Or then a decimal to binary conversion. We don't care. Okay? That if you want it, then you can try to see how can we do it. We already talked to you last time. Okay? And then the next will be using a hex to decimal conversion. Okay, if you get a number 356 base 16, that means hex decimal number. Okay, and if you want to convert into decimal, you take the 3 times 16, y 16, the thing is hex base 16, power 2. The thing is 3 here, left over 2 digits, that's 2. Then you adding to number 5 times 16 power 1, and so on. You get this number. That means if you get a hexadecimal number, you're able to convert it, okay, into the decimal. But really, we don't need that, okay? Hex to binary, that's what you need. The thing is, anything deal with a binary, make sure you have to understand. You get the number 9F2 base 16 in hex. You going to converting the decimal binary. You converting number 9. 9 will be 1001. must be 4 bit. Number F will be 1, 1, 1, 1. Number 2 will be 0, 0, 1, 0. Okay. That's what I said. The require binary 4 bit. Okay. And next you have to know how to convert binary to hex conversion. If you get a binary here, they want to know what hex decimal number. First thing, what you do, you can say count 1, 2, 3, 4. 4 bit, 1, 2, 3, 4. 4 bit. Then change one at a time. Okay? That means 1, 0, 1, 1. They will be equal to B. Okay? 1, 0, 1, 0 will be A. 0, 1, 1, 0 will be number 6. This is a very true thing, very important to you while you're working on the digital lab. Okay? If you get a question, anything, just bring it up. I hope I can help you out. BCD code, BCD binary code, decimal. When a number, letter, or word are represented by special group of symbol, this is called encoding. If each digit of a decimal number is represented by binary equivalent, this produces a code we call a BCD. Okay? Now, if you get a number 874 base 10, base 10 means decimal. Okay? And now, you want to convert into the binary. However, this binary they call a binary code decimal. First thing, you changing number 8, 1, 0, 0, 0. That's number 8. Okay? Have to be 4 bit. Then number 7, 0, 1, 1, 1. And number 4, 0, 1, 0, 0, BCD. Okay? Another one, access 3 code. Same as BCD. Except that 3 is added to its decimal digit before encoding in each binary. So, if you want to convert in a number base 10 decimal to the exact 3 code, number 4 adding 3, sorry, it will be a 7. 7 converting to binary 0, 1, 1, 1. Okay? And number 8, you get 8, 7, you get an 11. 11 will be 1, 0, 1, 1. Okay? This one we don't need that. Okay? The thing is, basically, sometimes they need the computer to control different kinds of machine. And that machine, they encoding into the exact code. So that's why they have to convert it to the exact code. Okay, alphanumeric code, ASCII, American Standard Code for Information in the chat. If you go into the Google, you type in ASCII, they given you the table. The table one will be a or B, A, B, C, or decimal, and the other side will be the binary number. So that's why they're recording into the computer. So when you're using decimal or just a character A, B, C, D, whatever, they convert into binary so the computer can understand. Next one. In electronic, binary represented by the voltage or current. Okay, normally you deal with voltage. You not deal with the current. Okay, first one they call it TTL, transistor logic. They define for you any voltage higher than V high here, less than V high maximum here. They will be high. High means logic 1. 2 volt up to 5.5. Okay. And any voltage from low minimum to maximum here will define low logic or binary 0. Okay. From 0 to 0.8 volt maximum. From 0.8 volt up to 2 volt. Undefined. Not using. Okay. I can give you example. When you get a point A, you measure 0.4 volt. What A equal?
Zero.
Telling me what A equal?
0 or low logic.
0. The thing is you need a number. Okay?
Okay.
If you get a B, okay, 3.5 volt. What B?
That should be 1.
Perfect. 1. Okay, if you get a C, 1.5 volt. What C?
Undefined.
Okay, undefined. That means you get a problem. The thing is when you try to working on your circuitry, you have to using the DMM meter or oscilloscope to measure the signal. When you measure, you get a 1.5 volt, guarantee. Your circuitry gets something wrong. Okay, undefined. Okay? So that's what they call a TTL logic. Transistor logic. You already learning transistor. NP. Basically, inside the circuitry, digital circuitry, they built by transistor. Okay? Sometimes you can see they get a CMOS. That means a different same thing for logic. However, the voltage will be a little different. Okay? That means logic high have to be 4 volt up to 5.5. Or logic low, they want it less close to 0. And they using the JFET to build for digital circuit. Okay? And now, this is what we call a clock signal. When you get a look like square wave here, keep going forever. Okay? And you get the time that go high, go low, then go high, go low, keep going forever. 14 0, okay? Then how long they will be go to 1, how long they back to 0, keep going. That's what they call a clock signal. Okay? Every computer you get a clock, master clock. So that's why when you buy the computer, they can asking you what frequency you want. Okay? High frequency computer will be running faster. Okay? And also, this they can select bit sequence represented by waveform. You get that one high, go low, high, low, low, high. That means any different signal. Okay? And now you can see you get only one. Low, 0, high, then go back low. Only one. That's what they call a positive going pulse. At T0, they go high. How long? They take a little long and go back low. Now, when you see this signal, you must understand it either positive going, okay, pulse, and the leg going up, we call a leading edge. Going down, trailing edge. Okay, same thing. You see another one go negative. Okay, that will be a negative going pulse. Okay, going down here, supposed to be, okay, trailing edge. Maybe that's wrong. Okay, going low, going up will be leading. Okay, and now when you get this signal here, from here to here, that's a one period. Okay, and that's telling you how long they will be high, TW. Okay, and how long they low. And if you want to calculate the duty cycle from going high to going high, you can calculate TW divide capital T times 100%. That means how many percent for duty cycle. They keep going forever. Okay? And now, when the data transmitted, the computer, they get two different types. One, they will call a serial data. That means they need only one wire. And this signal will be keep going. Okay? As long as they want. That's what they call a serial one wire. You see this happen in your telephone at home. Okay? The thing is, telephone at home, you get only one wire. They can transmit it too many bits, high or low. The thing is, when you're talking, too many bits, they cannot using the parallel. They must serial. Okay? When they go to the computer, then serial here must be converting to parallel data. Okay? And when they return, they have to go back to serial. The thing is what I'm telling you, inside the computer, they're not using serial. They just get a binary. Okay? So, in order for computer can understand that data, they must get the circuitry converting serial to parallel converter. Okay. Next one, parallel. That means what happen in the computer. You see 1Y, 2, 3, 4, 5, 6, 7, 8 bit. This is the old computer. They get a 8 bit of data. That means inside they get 8 wire for the data. How many wire for new computer right now we're using? Parallel 1 bit for 1 wire. Who knows?
Is it
Or-
64?
No.
Oh,
You have to using either 8 bit, 16 bit, 32 bit, 64 bit, nothing else. It have to be that number. This is for the old computer. They're using only 8 bit for the data. That means in the data line in the computer, they get 8 wire. Question A, for now, how many bits for the data line? How many wire? Answer will be 32. Okay? That means each time they transfer 32 bits. Must be faster than 8 bits. That's for data. For address. Okay, how many wires for address in the computer? New one. Okay, new computer. Address. $32 bit. No. 64 bit. Data. 32 wire. Okay. Okay, now let's give it to you the table. Okay. This is a decimal number. 0, 1, 2, 3, up to 10, 11, 12, 13, 14, 15. And this is a binary number. 1 bit, 2 bit, 3 bit, 4 bit. 0, 0, 0, 1, number 1, 2, 3. If you want to see the conversion, you can looking into the table. You don't have to memorize. However, 4 bit, better memorize it. Okay? This for your knowledge. You see that the computer here. Okay? Now this is keyboard here. When you typing number 9, what I telling you, computer cannot understand number 9. So that's why they need the circuitry called encoder. Encoder converting from a decimal to the binary. So this binary computer can understand. Okay? Anything outside, you want the computer understand, they have to be converting to the binary. That's what we call encoder. And now, opposite decoder. So, the computer will be sending out just a binary. However, the human cannot understand this number. So they get a circuitry they call a decoder. And that decoder converting binary to the output segment here. Then they have to go to the 7-segment display. They will display for you. For example, you type in computer sending out number 9. And that's why this segment here display number 9 or number 3, whatever. On your watch, they have to using that decoder. Okay? And the segment will be turned on, turned off, telling you either A or B, C, D, number, whatever. Convert following binary number to decimal. Okay? If you want to do it, you can do. We don't care. We don't need that. Converting decimal number to the binary. Okay? Basically, you get a decimal, you want to convert into binary. Then you can try. But we don't do anything with that in the lab. Convert following binary number to decimal, okay? Okay, we don't care that. Now we care about binary addition. You want to adding, okay, binary. This is the formula. 0, okay, subtract here. Sorry. 0 add 0 to get 0. 0 adding 1, 1. 1 add 0, 1. 1 adding 1 equals 0. However, you will be carry 1. Okay. Now, carry 1 means adding 1 to the next column. Last time I already showed you here. You have to working on that. That's what you need to know. Okay? I will be asking you in the test or in the quiz or in the homework. Next one, binary subtraction. 0 minus 0. Okay, 0 minus 1. Okay. 0 minus 1 with a borrow 1. Okay. Mean you get the borrow 1. Means subtract 1 from next column. And we already given to you here. Okay. 1, 0, 0, 1 minus 0, 1, 1, 1. 1 minus 1, 0. 0 minus 1, you get a 1. But you need to get the borrow 1 from next. That means you take 1 up here. 0 minus 1. Okay. You get a 1, 1 minus 1. You get a 0. Still borrow 1. Okay. Then 1 minus 1, 0, 0 minus 1, 0 here. So basically, 1, 0, 0, 1, number 9, and 0, 1, 1, 1, 7. The answer must be number 2. 0, 0, 1, 0, number 2. If you don't know number 2 or not, go back to this table here. Okay. Number 2. 0, 0, 1, 0. Okay, addition, subtraction. Okay, now we need to deal with the system, first complement number system and a second complement. Question is, why do we need the first complement number system? Or second, the computer using either one. Normally, computer now they just using second complement, not first complement. Okay, my question is, why we need the first or second complement? I can give you the example. You get a number 1, 0, 1. What number? in decimal.
It should be 5.
Perfect. 5. However, I don't want number 5. I want minus 5. You see that? That means we have to deal with a negative number. Okay? So that's why you need the first complement or second complement. They can take a both positive number and negative number. Now, how can we get a, you get a binary. 1 0 1 1 0 0 1 0. That's a binary. If you want to get into the first complement, very simple. Change 1 to 0, 0 to 1, keep going. No problem. Then the next number, they will be in first complement. Okay? Now, second complement. For the second complement, the first thing, you get a number here. Binary. You want to change to the second complement. What you have to do first, find the first complement. Okay? Then you adding 1. You get the second complement. Okay? That means second. Any question? First complement. Second complement. Okay? This
When
one you have to do.
when you say add 1, are you saying add 1 to each column? Add 1, carry it over, or how?
Now. Okay, you see right here. You get a number, right?
Mm-hmm.
You find the first.
Right.
Then now you add into 1. 1 added to 1, 0. Okay? Then keep going. 0, 1, 1, 1. Okay? Then you get a second. Okay? So in here, first thing they say, they want first complement, that's okay. Easy. 0 to 1, 1 to 0. However, if the second, first thing you have to find out is to the first. Then you adding 1. Okay? I can pick one example here. Number B. Okay, you get 1, 1, 1, 1, 1, 1, 0. Okay, that's a binary. Now, first complement. 0. Correct? Adding 1. 1 added 1, 0. Okay, 1, 1, keep going. Okay? Now, that is the next one side. Okay? Basically, this will be going to more detail. And basically, we don't need to, go to too many detail on that. Okay? They just telling you in digital system, okay, like computer, they must able to handle both positive, negative number. So that's why they get the sign, okay? Like you get a 0, 0, 1, 1, 1, 0, 1. It's a bit here, 0. 0 for positive, okay? And if the bit side 1, that means for negative number, okay? But we not do anything with that. First complement, second complement. We don't care, we don't working on that thing, okay? Convert following binary number to the hex. This really we need. Okay, they given you the binary and they want hexadecimal. The way to do 4 bit for each from right to left, 1, 2, 3, 4 here. First one. And the next 4 bit. This will be okay, 1 here, 1, 2, 3, 4 here, 1, 2, 3, 4 here, 1, 2, 1, 2, 3, 4 here. Can you tell me the hex number? What is it? That's what you have to know. Just converting for each group. The first thing you get only number 1. So decimal will be 1. The next one, 1, 0, 0, 1. What number?
Let's see.
1, 0, 0, 1.
9.
Perfect. Okay. Next one, 0. Let's see. 1, 0, 0, 1. Then you get a. Okay. Make sure. I have to make sure. Okay, we can get the right selection. 1, 2, 3, 4. 1. 1, 2, 3, 4. 2. 1, 2, 3, 4.
A.
2, 3. Okay. So now the first one here, 1, 1, 0, 0. What type?
C.
C. Okay, now if you don't know, you have to add. Okay, this is what you have to do all the time. All the time when you try to working on the lab. Anything question I can help you out. No big deal. The next number, 1, 0, 1, 0.
A.
Perfect. 0, 1, 0, 1.
5.
Last one.
7.
Perfect. If you know how to do it, that's very easy. Okay? So that's what you need to go through it. Okay? And
Okay.
try to do. For example, related problem here. Okay? You try to do it. This is the table. Okay? Using all the time. If you don't know, you're looking into the table. Okay? 1, 1, 1, 1. Okay? That means decimal 15, but the height could be F. Okay? For a while, you get along. You don't have to see the table, like myself. Okay? Converting number to the BCD, you need to looking into here. Okay. Until you're not quite following how to do it, and I will be with you. But that right now, we don't need that. Okay, adding here. Gray code. Okay, let's see. A different type of the code. Okay. This is a binary gray code. Okay. 0789. They just given you the table. Okay. Binary to gray code conversion. Okay, this one basically you need to know, but nothing apply for your job. Okay, just for your knowledge. I can tell you, you get 10110 binary. Okay, they want the gray code to convert it. What you do? First thing one, you put a 1 here. First one. Okay. 1 you add into 0, you get next will be 1. 0 adding to 1, you get a 1. 1 adding to 1, what you get?
0. 0.
0. However, carry what? Correct? If you open adding, 1 adding to 1, you get a 0. However, carry 1, but they're not using carry here. They ignore the carry. So now 1 adding to 0, you get a
1.
1. That's it. Very simple. That's just for your knowledge. Okay. If you get a binary, you say, I want to grade. Then you did it away. Okay. And that's the example. Related problem you can try. Okay. Now, a next one. You get the gray code. Yeah. They want to change to the binary. Now, one one zero one one. It's a gray inside gray code. If you want to change to binary, first thing one, you put a first one here. Okay, and 1 adding to 1, what you get?
0.
1 adding to 1, you get a 0. Okay, carry 1. And 0 adding to 0, you get a 0. After you get a 0 here, you adding 1, you get a 1. 1 adding to 1, you get 0. No carry. Okay? ASC, we don't care. Okay, now, these are important for your knowledge. Boolean. Algebra. This is a math in the computer. First thing they're talking about, variable. You can using A or B or C. Doesn't matter. That's what they call variable. Okay? In computer. Now, you tell me what A equal.
A equal A plus A.
A equal what? What number? You understand in computer,
Any number?
One,
the binary,
one,
you get only two number, right? 0 or
one,
1. If not 1, then 0.
right,
If not 0, then 1.
right.
That's why I say A can be equal 0 or
One.
A can be 1, nothing else. That is variable. Now they get the rules for Boolean. Basically, you need to know. If they get A, you adding 0. What you get will be A, right? If A 0, you add 0, you get 0. If A equal 1, 1 adding to 0, you get what? Now, A adding 1. A adding 1.
Equal one.
Now, equal 1. I can prove for you. A can be 0. Or they can be 1. If A 0 adding 1, they equal 1. If A equal 1 adding 1, they have to be 1, not number 2. Okay? In the computer logic, we don't have a number 2. Just 1 or 0. So A times 0, then you get a 0 for sure. A equal 0 times 0, you get 0. A equal 1, 1 times 0, you get 0. Okay? A times 1, you get A. Or A times A, you get A, not 2A. Okay? A times not A. Okay, A times, you get a bar over. That means not. For example, if A 0 times adding to not A 0 not A have to be opposite 1. That you get 1. A equal 1. Adding to not A, not of A will be 0. And you get a 1. So that's why you can see here A or not A equal 1. Okay? And so on. A times A times not A, not and not. Okay? Equal A. A, not, or this way. A, not, equal A. For example, A 0. Okay? Not, then not 0. Not 0 will be 1. And not again, go back to 0. If A equal 1, not 1 will be 0. And not 0 go back to 1. So that's why. Okay? Not and not equal A. Okay. Another thing, A or AB. Now, try to see. How come A or AB equal A? A or AB. they say equal A. How come? First thing I'm telling you, A or AB, you can say A, open the bracket here. That will be A, here will be a 1. A, B, B. Okay? 1 or B equal what? What 1 or B? What B can be equal? B can be equal 0 or B can be equal
1.
1.
B or 1.
B can be 0 or B can be 1. My question is 1 or B equal what number?
0.
Now you try. If B 0, 1 or the or adding 0, what you get? Must be 1, right?
Yeah.
And then if B equal 1, so 1 adding 1, what you get? You cannot get number 2.
No. So you get 1.
So that's why 1 adding to B, you get 1. 1 times A, that's why they equal A. A or AB. A adding AB equal A. Okay? Number 11. Okay, I have to double check. Okay? But that for very general. Next one. De Morgan law. Sum of product. That means you get X times Y, not X times Y. X times Y, you get a not. When you get a bar over, that's a not. Or sometimes we have to using X times Y. This is the same thing. Okay? You want to remove that bar over here. Then X will be not X. Okay? Time Y now will be adding Y. Okay? Not Y. That's going from X times Y means the product, and this will be a sum. That will be a product. And the other side will be the sum. Now, if you get the product here, sum here, not X or Y, you want to convert it to the product. X now will be not X, Y will be not Y, but will be a time. Okay? That's just changing from product to the sum, or the sum to the product. Okay? For example here, what they say right here. Okay? Basically, A or B, A plus B plus C times D, not. Okay? Let's see. A or not B, not C. Everything will be time D. Okay. And basically, you get open here. You get close here. Everything will be not. So, first thing you need to break this bar over everything. A or B plus C. Not A plus B plus C. Later on, I call or. Not. Okay. And now this is a multiply. And they converting to the or. D. Not D. That means I want to break the bar over. And now you break the bar, this bar over here. A. They get not A. This is the blood or go to the end. Not B. Or go to the end. Not C. Or not D. Okay? That's just for you guys to know how to using the Morgan law. They go in converting product into the sum or the sum into the product. Okay, now this is the real thing.
Can you go back to that screen for a minute? Hang on a second.
Yeah, no problem.
Okay, just give me 1 second.
Make sure, okay, if you really want to understand anything confusing, just bring it up. Okay, when you do your assignment, you do your lab, you
Okay,
develop your software, okay, you get a problem. Normally Monday, I will be in the class, okay, I will be help you.
okay, thank you.
Guarantee you know what you're doing. Then that will be later on more easy for you to get everything done.
Okay, thank you.
Yeah. Now, this is a real. That's what deal with your lab. Deal with the real thing. Okay. First thing they talking about the AND gate. If you're looking into the symbol, okay, and you get the, if they draw this one, they are AND gate, they get one input A, one input B, and the output here Y equal A times B. A times B, we're not using time, we say A and B. Okay, the truth table here, you get two input A and B. Okay, when you get a two variable, how many combination of two variable? Two variable. So 2 power of 2, you get 4. Four combination. First thing, get 0, 0, 1, 1. Then the next one will be 0, 1, 0, 1. That is the combination for 2 variables. If you get 3 variables, how many combinations? 3 variables.
You get 3.
Will be 3 power of 2. Oh, sorry, 2 power of 3. Then you get 8, right? 2 power of 3 means 2 times 2 times 2. You get 8 combinations. That means you get first one will be 4, 0, 4, 1. The next will be 2, 0, 2, 1. The last one will be 0, 1, 0, 1. And if you get 4 variables, 2 power 4 will be 2 times 2 times 2 times 2. You get 16. Okay? That's what given to you the truth table. Depending on how many variables. Okay, now, if you're looking into that table, B0, okay? Zero, zero, output 0. 0, 1, output 0. 1, 0, output 0. 1, 1, output 1. Okay, that only telling you if you get a 1 here, 1 here, then output equal 1. Now I given you example. You get A. When you measure A, okay, you get 3 volts. You get a B. Okay, you get 4 volts. Then Y will be equal. What do you think Y will be equal? Not 7 volts. Okay? In the binary, we don't care about the voltage. We care about logic. A, you measure 3 volts. That telling you A logic will be
Logic
1.
1. Yeah,
B logic will be
1.
1 adding 1. Right?
Yep.
Or 1 times 1 till 1. So that telling you if you measure the input, okay, logic 1, next input logic 1, then output have to be 1. Okay? If you measure one input 0, no matter what the other input, output must be 0. You see here? 0, then you get 0. Either one get 0. Okay. Now, this is the key point to memorize. Output is 1 if all inputs are 1. Only, one input 0, output must be 0. If you want the output to be a 1 for the AND gate, then all of the input have to be 1. I given you another thing. Now, 0 here, 1 here. What output?
0.
0. Right?
Mm-hmm.
Okay, now, when you get a problem, okay, you take your meter. That means in this one, you 1 0. However, when you measure in here, not 0. That means you can get 1.5 volt. 1.5 volt is not logic. You want. They can be either higher than 2.8 volt, or they will be less than 0.8 volt. They have to be either 0 or 1. Okay? And now if you get not logic, you know wrong, then what can you do? If you measure output, you not get what you want, what can you do? Who knows? Again, I repeat on this thing. When you get apply 0 here, 1 here, output must be 0. Depend on the table. However, you not measure here, you get 1.5 volt. It's not 1, not 0, you know wrong. How can you fix the problem? That is what we're talking about troubleshooting. Tell me, how? What can you do?
Check A or B.
Okay, now, first thing, you measure A. Measure. Okay? When you measure, you can get what you want, or you not get what you want. Okay? When you measure at A, you get 0. I can say that you want. You need 1. If you measure at pin A, you get 0. That's what you want. Tell me what next you want.
Measure B.
You have to come up with something. Tell me. Again, you measure the
Measure B.
output you want. You want 0, but you not get that. You know something wrong. You have to take the input. First thing you take the input A. You want 0, and you get 0. Next step.
Measure B.
Okay, that's what I'm telling you. That's wrong. Okay, now what I said. If you're reading this one here, they said this and get output is 1 if all input are 1. Okay, and 1 input 0, output must be 0. They just AND A times B. If you times 0, anyway, you get 0. So, will be that must be don't care. Later on, you can understand don't care. Don't care mean what? That means they can be 1 or they can be 0. That doesn't matter. That's what we call don't care. Okay, now you know that you want it wrong. When it's wrong, you need to change that gate. That you want. Okay? And you give it to assembler, they change it for you. However, the supervisor will be asking you, why you want to change U1? And you say, okay, I want output to be 0. However, it is not 0. I take the input at A, I get 0. Okay? Then the output must be 0. If it's not, that means the IC not working.
That's
I'm
right.
talking about taking at B. If you say I take at B, I get whatever here, you're wrong. Why? The thing I did at the AND gate 1, 0, output must be 0. Otherwise, they be wrong. This one don't need it, don't care. Why you take it? We don't want to do extra work. Okay? That's how to troubleshoot it. This is the IC for the AND gate. Okay? The part number they given to you here. 7408. That's the part of the AND gate. Okay? And if you're looking inside, how many gate? 1, 2, 3, 4. For gate inside one IC. IC means interface circuit. Okay? And if I looking into the IC here, they tell me pin 1, input 1, pin 2, pin 3 out for first one, and second one, next one, and next one. What input, what output. And inside the IC, how many pins is here?
Are you talking about 4, 5, and 6?
Now, how many pins total?
Oh, how many pins?
1, 2, 3, 4, 5, 7, up to 14.
Mm-hmm.
Okay, normally the IC they need a power 5 volt. That's what VCC 5 volt connect to pin 14. However, they have to get a route. Route connect to pin 7. If the IC don't have a power route, they're not working. The thing is, I understand that one IC, one gate, then you can understand the rest, no big deal. That's what we call a 7408 AND gate, 2 input AND gate. Okay, any question up to that point? Now, otherwise, you can go to the OR gate. Same thing, okay? OR gate means if you get for OR gate A and B input, output will be equal A plus B, A or B. And this is the truth table telling you input A and B and what output. Okay? However, this is a key point for you to memorize. Output is 0 when on input is equal 0. Okay?
Okay.
That means you get a 1 here, you get a 0, no matter what, I know output must be 1. The thing is 1 plus 0 or 0, they 1. Only thing is you get a 0 and 0, then you get 0. Okay? And the part number 7432. Okay. And also telling you, inside same thing, you get a 14 pins. Power down. And this is the first gate, second, so on. What pin in, what pin out. Okay? Next one, inverter. Not gate. 7404. How many gate inside?
Six.
What was the question?
How many gates inside 7404?
Six.
6. 1, 2, 3, 4, 5, 6. 6 gates inside one IC. Pin 1 input, the first one 2 output, so on. Okay? Power still 14. And out still number 7. When you start working on the lab, you will be deal with that gate, that integrated circuit IC. Okay, next one. NAND. Yes. NAND means not add. And it's the same thing. Truth table. Okay? You're looking in the truth table, you can tell them what the output. Okay. Now, try understand right here. NAND means not AND. That means they get the AND. And they adding the inverter. They will be a NAND. Okay? A and B here. Output here A and B. And now you put a bar over A and B, not A and B. Not A and B using the one we already passed through it. Okay? Changing from product to the sum. So basically, okay, A and B will be not A or not B. Okay, you see not A or not B. This is the truth table. 0, 0, you get output is 1. 0, 1, output is 1. 1 or 0, output is 1. 1, 1 is 0. Now, I get a question. 1 or 1 or 1 or 1 equal what? When you get adding 1 to 1 to 1 to 1, what you get?
One.
Get
Yummy.
0. You get 0.
Come on. You said you get 0. Who else?
Are all the inputs, what are the inputs?
I don't care in or out. But I say I get 1 and adding 1, adding 1, adding 1. What do you think? Not 4, right?
No, to me, you should get 0 because the
No,
truth
we're talking
table, wait a minute,
about
Mr. Pham, wait a minute, Mr. Pham. The truth table says the only time you can get 0 is when you have all ones. And based on what you're saying, it sounds like you got all ones. So if you got all
I'm not
ones,
talking about that. You're talking about the NAND.
that's
Man,
right. That's what you're talking
No,
about.
no. I'm talking in general. If you get 1 and 1 adding to 1 adding to 1, what do you think?
1.
1. Perfect. Now, try to understand that one. When you're working on the circuit, they connect to 1. Where you connect to?
In 1.
Ha! You
No,
can
you
see
connect the 5 volts, which is pin
Exactly.
14.
exactly. In the lab, you can get only 5 volt and ground 0. If you connect to 1, that means you connected to 5 volt. If you connect to ground, that means 0. Okay? Remember. So that's why when you connect to 1, A connect to 1, B connect to 1, that means A you connect to 5 volt, B connect to 5 volt, or C connect to 5 volt. Connect to 1, that means connected to 5 volt. In the lab system, you get only 2 power. 1 power for 5 volt and 1 for the ground. And did nothing else. Okay?
5 volts is logic 1.
Right.
And logic 1 is always, on this particular IC, it's always pin 14.
Right. Connect to 5 volt. Okay, now they're telling you inside here 1 gate, 2 gate, 3, 4 gate. Okay? Input 1, 2, output 3, so on. You understand the first one, that this is not big deal. 14 pins, 14 VC, 7 will be ground. And this is the IC how they look like. Okay? In order to identify pin 1, you see that this one is not normal here. And you get a dot here. So that's start from 1, 2, 3, 4, 5, 6, 7. And this 8 to 14. Pin number 1 identified. Okay?
Okay.
And this is the truth table. Okay, for the NAND gate. Okay? Output will be equal 0. On input must be 1. Only 1 input, 0 output must be 1. Okay? And now, that will be
Hey,
no.
Mr. Pham, real quick,
Yeah.
do these gates, they come in more than just the input with 2 pins? Some of them come with 3 pins or 4 pins?
What you mean?
I'm asking you, I'm asking
Yeah,
you,
what you mean? Input or
asking-
output?
I'm asking you, do they come with more than, say, 2 pins on the input?
Oh, 3 pin?
Yeah, right.
Yeah, depending on IC. Okay? Depend on the IC.
So if it comes with 3 pins,
Yeah,
then
3 pin, 4 pins, doesn't matter.
no, but wait a minute, Mr. Pham. So if it comes with 3 pins and you get all ones on the 3 pins, then the output should be 0. Is that correct?
All right, that's what they said.
Okay, all right, thank you.
The IC, they get a 1 output. Okay. However, the input is not 2. This is standard. You can see you get 3, 4, 5, 6, up to 20. Okay?
Okay, I get you.
I see.
The input can have more than 2 pins.
Right. And now the part number. This is the part number. 7400. When you start lab, you can see that. Okay? If you give them to the schematic to the instructor, you say, okay, I want one IC 7408, another one IC 7400. Then they know what IC you need. Okay. This is the NOR gate, NOT gate. Okay. This is what get in. NAND. Okay. This is will be NOR. NOR just opposite to the NAND. Okay. When you get A, B, 0, 0, output 1. Any input get logic 1, output must be 0. That is easy to memorize. Same thing. 14 pin, power, route. 1 gate, 2 gate, 3 gate, 4 gate. What input, what output. Okay, I hopefully you can understand that. Okay, almost done. Now that one, quickly. Okay. That's what exclusive or exclusive NOR. When you see symbol like that, that's what they call exclusive NOR. Or they're telling you this is a true table. They get only two. True table for exclusive OR gate. Okay. Two input A, B, you get a 4 combination. 0, 0, 1, 1, 0, 1, 0, 1. Okay, when 0, 0, you get 0, 0, 1, you get 1. 1, 0, you get 1. 1, 1, you get 0. Okay, this is the input, this is the output. Okay, if you input the same, output will be 0. If the input different, output will be 1. Okay, this you get a not here, just opposite to that one. Okay, basically this using for checking. When you send the data, when they go up to the other place, make sure guarantee you get the same data. If you get a different data, you get a big problem. Like you get all, you deposit 100, when they send it into their computer, they change the bit. So you can get a different value of money. That not happen. So that's why they have to using this exclusive OR. Okay. To check to see the data you send and the data they supposed to get, is it the same or not the same? Okay. When you go into that IC detail, later on the circuitry will be explained to you. Error checking. So, what I want you to do, okay, go over. When I asking you, okay, then you're able to telling me exactly what I want. The thing is, you remember, normally we get the lecture on Friday. And sometime I will be meet you guys on in Monday on room 240. Okay, especially when we're talking about the lab circuit board, how to build, how to do anything regarding into the process of the lab. After you get the first lab done, you know how to do what to do. Hardware and software. And later on, okay, we don't have to in-person meeting. Okay? That will be very easy for you if you already know how to develop your program. How you know how to build the circuitry. How you test the circuitry. Okay? That is the process for any lab later. You know how to do the first one. And the next one, only the concern is try to understand the circuitry in the lab. How they work. How many input, how many output, whatever. Okay, any question, anything?
When is the first Monday meeting?
Not this Monday, but I believe next Monday.
You'll let us know next time, right?
Yeah. That means next week meeting on Friday.
Okay,
Zoom.
I believe, I can guarantee, then we will be get together. Okay? And also, the other thing, you understand, in order to do the lab, you need the circuit board. Circuit board right now, we don't have it. However, I want to see how many people need. Normally, one circuit board costs around $30. So everyone have to get one if you want to do the lab. Okay? You cannot buy one. The thing is, you buy online, they don't want to delivery only one. Got more money. So that's why we can buy 10. Then that cost around 30 or less little. Otherwise, you have to pay 45. At
so
least
do we just bring the money to you then?
that's what I try to tell you. Okay? I can try to buy 10. You want to get it, pay me $30.
Okay, I'll bring money Monday.
And that's what next week we want to get that circuit board.
Okay,
And anything else, like the wire, okay?
okay,
We supply for you.
okay,
Okay, a tool. That means how to cut the wire, okay, how to do whatever with the using the tool. We try to see what else we get. I let you borrow.
okay.
Okay, that means only thing you have to pay for the circuit board.
Okay, thank you.
Okay. So, any question, anything else? If it's not, okay, we will stop here, okay?
Okay, thank you.
You're welcome. And I, with your guy, get a good weekend, okay?
Yeah, you too.
Okay, thank you. Thank you, everyone.
Thank you.
you,
Nice to
Ken.
hear your voice, Joseph.
night.
Okay, very good. Bye-bye.
Bye-bye.